It's taken a while to get back onto this project, starting by getting the ways scraped. They were not very well machined to start with and required a little bit of TLC to get them running okay. Using Mechanics Blue onto a machined block of steel allowed me to find the high spots to scrape down to enable the saddle to run smoothly. Similarly on the top sides, using a jig with a right angled former enabled finding the high spots there as well. This was tedious work, but well worth it in the end. Got good results and enabled the saddle to run smoothly. Here we're doing the wiring of the saddle before testing it. Testing the operation with a cordless drill to see if there were any snags. The electronics are fairly straightforward. Power supply, 2 driver boards and a breakout board for USB connection. I was surprised at the amount of information on Google. So many users in so many different countries and information freely available. All the control is done for you on the breakout board. To get the motor to turn, you just need to pulse it on one channel and define the direction to turn. Here we are doing the final connections and wiring up of the control box. Technology is amazing. Testing the hardware on my bench while at the same time watching a live stream of a safari on Wild Earth.
Taking the time to be interested in it, I think, is the number one rule of starting point, having a passion for learning about what's in your backyard, and that'll translate into visits to national parks or provincial reserves.
The hardware tested out okay. Software is free to download from a variety of sources on the internet. I'll describe the software in more detail in the next chapter. Assembling the electronics in a control box on the machine. Stepper motors are a remarkable method for low-cost automation. The rotor and stator have about 200 teeth to provide 1.8 degrees per step. This could be further divided in the hardware by a factor of 10 to produce 0.18 degrees per step for extremely fine incremental control. Ball screws are precision ground devices enabling very accurate positioning with zero backlash. Running a short program to check the repeatability of the hardware and the software. I was amazed at how accurate it really was. The repeatability was spot on. I couldn't see the error on my 10 micron per division instruments. The next stage was to decide on a tool post and tooling to use. The center height is quite high above the saddle. so I had a bit of head scratching. Checked on the internet as to how commercial machines did it, and decided on a bit of angle iron and a tool holder to provide for turning and facing in different orientations. Deciding on the tooling to use was another learning curve. I tried grinding my own from high-speed steel blanks. Didn't work too well. Then decided on using a tipped tool ground in a very sharp angle with a groove down the center, which seems to match what was used on commercial machines. This worked relatively well with good results. Final assembly of the saddle. This chapter has been long in coming for various reasons. The next chapter will deal with the software, assembly of the machine, and maybe turn something. I've really enjoyed the journey of this project and still have no idea what I will do with it ultimately.